Good morning. This is Dr. Ilango, Professor, Department of Electrical and Electronics Engineering, K.S. Rangasamy College of Technology. From this video, I would like to explain 8255, that is Programmable Peripheral Interface. Right. From this class, I would like to explain the following. What are the methods of parallel data transfer? Need of 8255 IC, that is Programmable Peripheral Interfacing IC. What are the pin details of 8255, block diagram representation of 8255, and finally I would like to give the explanation of control word of 8255. Okay, the first one, methods of parallel data transfer. When we have to consider the parallel data transfer, there are four methods. The first one is simple input and output data transfer cases. Right? See, this is the characteristics curve. This is the diagram representation for simple input and output. Right? From the name itself, we can easily understand what is simple input and output without checking anything. Right? Without checking anything, whether the peripheral devices are ready to transfer the data or ready to receive the data, and similarly processor is ready to receive the data or transmit the data. Right? Without checking anything, simply we are transmitting the data from peripheral devices to microprocessor and vice versa. That method is called as simple input and the output data transfer. Right? Here the second one, simple strobe I/O. Whenever the strobe signal activated low, whenever the strobe signal is activated low, right, from that the processor came to know that peripheral devices need data or peripheral devices ready to transmit the data. Right, with the help of this strobe signal, data is to be transferred from peripheral to microprocessor and vice versa. This is called simple strobe I/O. This is the second method. And the third method, they are using two number of handshaking signals. One is strobe signal and another one is acknowledgement signal. Right? From strobe signal is normally transferred from peripheral devices, and acknowledgement signal is normally transmitted from port devices to peripheral devices. Right? See, from these two signals, what is this? The port came to know that peripheral devices are ready to transfer the data, and port device is also ready to accept it. Right? Ready to do that operation. If it is so, what is this? By checking these two conditions, data is to be transferred over that. This is called a single handshake I/O. And the fourth one, double handshake I/O. Here it is also using the two number of signals such as strobe and acknowledgement signal. But here the strobe signal is activated 2 times. Acknowledgement signal is also going to be activated 2 times. Normally here for this double handshake I/O, strobe signal is activated low, then again it is getting into high. Right? And acknowledgement signal is initially it is low, and once if it is strobe signal is low, right, that acknowledgement signal will send to processor, and came to know that processor is also going to ready to do that operation. So here the acknowledgement signal is activated high. Right? Then again the strobe signal is activated from low to high. See, this is the second indication, and again the acknowledgement signal is also going to activate it high to low. Right? See, this is the second activation. So here the two number of signals are activated 2 times. It is called as double handshake I/O. After these two number of signals activation, data is to be transferred over that. It is called as a double handshake I/O. Data transferred after the first strobe and acknowledgement is going to be do with the help of the cases. So this is the four methods of parallel data transfers. Right? And need of this 8255 is the 8255 will be done the both the cases. Right? See, previously we done right, handshaking method of data transfer. Right? See here that 8255 is going to receive the signal from the peripheral devices, whether the peripheral devices are ready to do that operation or not. Right? Similarly, the 8255 IC is going to send the interrupt signal to microprocessor, and from that signal the 8255 came to know that whether the processor is ready to do the operation or not. Right? So by using these signals, it's synchronizing the data transfers operation. Actually, the 8255 is going to act as the mediator in between the peripheral devices and the microprocessor and organize the data transfers operation. This is the need of this programmable peripheral interfacing IC, right? When we have to look at the programmable peripheral interfacing IC pin, actually it is the 40 pin IC package. Totally it has 40 number of pins, right? And for this 8255, it has 3 number of ports, port A, port B, port C. Each port are bidirectional 8 pin port. That means at a time 8 number of data is to be transferred from peripheral devices to microprocessor and vice versa, right? So here 8 pin, port A 8 pin, port B 8 pin and port C 8 pin. In addition, data transfer, actual data transferred from peripheral devices to microprocessor. Additionally, it requires additional 8 pin. So totally 32 number of pins are going to be used for the cases, right? So here 32 minus 40, remaining 8 number of pins are that. It is those 8 number of pins are used for the controls, right? For chip selection, read bar, write bar, and A0, A1 is used for port address, right? Here it has 3 number of ports are available, port A, port B, port C. So here the microprocessor is going to select which port is going to be activated for data transfer, right? For that cases, address line A0, A1 are going to be used. 00, 01, 10. So by this combination, ports are going to be used for the cases, and chip selector signal is used to select the particular 8255, and read bar, write bar signal is used for read operation and the write operation, and VCC and ground signal is pin are going to be used for giving the electrical power supply to this 8255, right? Without power supply, nothing going to be, no electronic devices are going to be functioning, right? So in order to give the plus 5 volt power supply to this 8255, VCC and the ground signals are going to be used, right? Okay, then block diagram of 8255. See, from the pin details of 8255, easily we came to know that it has 3 number of port, port A, port B and port C. Here actually that port C is divided into two parts. One is lower port and another one is upper port, right? The lower port PC0 to PC3, it is those 4 number of signals are going to be act as the handshaking signals for port B. Similarly, PC4 to PC7, remaining 4 pins, that is upper port C, is going to act as a handshaking signals for port A. So here port A and the upper port C will be acting in a group, is called group A control, and the group B, port C lower and port B, these are going to be act as the group B control. So both two groups are going to be activated for the data transfers operations, right? And this is data bus buffer. With the help of data bus buffer, data signals are going to be improved over that, and remaining control signals, 8 number of control signals are there. This will be read write control logic is going to control the read operation, write operation, and port selection, that is A0, A1 port, and reset, and chip selection is also going to be taken care of this read write control logic. Once the 8255 is going to be functioning, chip selection is needed for the cases, right? So this is the internal architecture or functional block diagram of 8255, right? Very simple. It has 3 number of ports, port A, port B, port C. Port C is divided into two parts, upper port C and lower port C. Upper port C combined with port A for handshaking signal, lower port C combined with port B for handshaking signals, right? So port A and upper port C acting along in group A, and for group B, port C lower and port B, right? This is the architecture of 8255. Then control word format. Before the control word format, first I would like to give the explanations about chip selections, right? See, A0, A1 is normally used for the port selections. See, if both signals are 0, A0, A1 both are 0, port A is selected. 0, 1 means that is A0 is 1 and A1 is 0, port B is selected, and A0 is 0 and A1 is 1. Port C are going to be selected, right? So this is the combination where we had to choose the port A, port B and port C. And for chip selection, normally the signal is going to be 0 because this is active low, right? And write bar operations, what is this? Write bar signal is going to be activated. So this is port A, port B, port C. These are going to be act as the data bus for write operations. Okay, so sorry, read operations, right? Read bar. Okay. Then for write bar operation, what is this? Again, A0, A1, 0, and for port B, A0 is 1, A1 is 0, and for port C, A0 is 0 and A1 is 1, right? So before going to do these operations, first we had to set the control word and it must be given to the control word register, right? For this control word register, A0, A1 both must be 1 and the read bar signal must be 1 for the cases, right? So this is the control word format to write the control word to control register, right? So here, what is the control word format? See again, the control word format of 8255 is the 8-pin port. It varies D0 to D7. Here the D7th bit is used for I/O mode or BSR mode, that is bit set or reset mode. And the first one, the I/O D7th bit is 1. It is simply act as the I/O mode, that is input or output mode, right? Then D5 and D6 are used for mode A selection, that is group A selection, right? Group A, it has 3 number of modes, mode 0, mode 1, mode 2. In order to select those 3 number of modes, D5 and D6th bit are going to be used. 0, 0 means mode 0, 0, 1 means mode 1, 1, and the D5th bit is don't care, mode 2 is going to be selected. And for this group A, port A will be acting as input port. The particular pin, D4th pin is 1, and the port A is going to be act as the output port. The D4th bit is 0. Similarly, port C upper, because the port C upper and port A will be acting along the group A control. Again, port C upper is going to be act as the input port. D3rd bit must be 1, right? Similarly, port C upper is going to be act as the output port. The D3rd bit must be 0, right? Then remaining 3 bits, D0, D1, D2 is used for controlling, giving the control word format for group B, right? Here, the group B will be acting with only 2 number of modes, mode 0 and mode 1. If group B is under mode 0, what is this? D2 bit must be 0, and the group B will be acting under mode 1, the bit must be 1. Similarly, port B and port C lower is going to be act as the input port or output port, depend on the number of depend on the bit will be given into D1 and the D0, right? So this is the control word format of 8255, right? See, from this class, I have given the explanations for what is parallel data transfer, what are the methods of parallel data transfer, what is the need of 8255 programmable peripheral interfacing IC, what is the pin details of 8255, what is the architecture or functional block diagram of 8255, and finally, what is the control word format of 8255 I had given. Thank you. We will meet in another video.